Question 13. Find the volume of the solid generated by revolving the region bounded by the curve y equals x square and the straight line y equals 2x. A complete revolution about x-axis. Solution. Let y1 equals 2x and y2 equals x square. This is to find the points of intersection of these two curves. We will put x square equals 2x. We will put y2 equals y1. And x square minus 2x equals 0. By factorization, we take x as a common factor. We have x multiply x minus 2 equals 0. So x equals 0 or x equals 2. And we draw a simple figure to represent the two curves. We have this curve. It is a straight line. y1 equals 2x. And the second curve is a quadratic function, quadratic curve, y2 equals x square. And in this interval 0 to 2, y1 is drawn above y2. So the volume equals pi, the integral of y1 power 2 minus y2 power 2 with respect to x from 0 to 2. From 0 to 2. It is the points of intersection from 0 to 2. And we complete substituting y1 equals 2x and y2 equals x power 2. So y1 power 2 equals 4x square and y2 power 2 equals x power 4. And we start integration. We take pi out of the bracket. And what is the integral of 4x square? The integral of x square is x power 3 over 3. So the result will be 4 over 3 x power 3. And what is the integral of x power 4? It is x power 5 all over 5. And we write 1/5 x power 5 from 0 to 2. And then substitute x equals 2. Substituting x equals 2, we will get pi multiply 32 over 3 minus 32 over 5, which equal minus 0. Minus 0, substituting x again equals 0, minus 0. So the result will be 64 over 15 pi. So it's very important at the beginning of solving this problem to determine the point of intersection by the equating of the two curves, x square equals 2x. And then we determine which is greater, which is bigger, y1 or y2 in the interval from 0 to 2, the interval between 0 and 2. And we notice that y1 is greater than y2. So we write it and we substitute. And notice that here it is the revolution, it is about x-axis. So the integration will be with respect to x. And substituting y1 and y2. And do complete solution by making the integration. So the final result will be 64 over 15 by volume units. Question 14. If y equals a e power b over x, prove that x y double dash plus 2y y dash minus x multiply y dash all square equals 0. We notice here we have b over x as a power of e. We have a variable on the power of e. So to find the first and the second derivative, we taking the logarithm to both sides as follow. Ln y equals ln a multiply e power b over x. Here we have a multiply e power b over x. We write it. It means ln a plus ln e power b over x. This is from properties of logarithm. The multiplication will be addition. And it is equal ln a. Ln a is a constant. Plus p over x multiply ln e. Also, we use the properties of logarithm because ln e equals 1. So the result will be ln y equals ln a plus b over x. Multiplying by x to get rid of x from the denominator. We got x ln y equals x ln a plus b. X multiply b over x equals b. And we making the differentiation to get the first derivative. So we have x multiply ln y, product of two functions. We use the rule. The differentiation of the first multiply the second plus the second multiply differentiation of the second function. So the differentiation of x is 1 multiply ln y. We write 1 multiply ln y plus x. What is the first derivative of ln y? It is 1 over y dash. Y dash because the differentiation here is with respect to x. So we use the chain rule. Derivative of ln y, it will be 1 over y. Multiply the derivative of this function. The derivative of y is y dash equals x ln a. Its derivative equals ln a because ln a is a constant. So the derivative of x ln a equals ln a. The derivative of b equals 0. And then by differentiating both sides with respect to x to get the second derivative. So we must make the differentiation again. The derivative of ln y equals y dash over y. Again, the derivative of ln y is 1 over y. Multiply y dash. So the result will be y dash over y. Here we have two functions. The first multiplies the second. And we use the rule. The derivative of this product is derivative of first will be 1 multiply the second. So it will be y dash over y here. 1 multiply y dash over y plus the first multiplying the derivative of the second. The second here is a fraction. So we write x multiply the numerator multiply derivative of numerator will be y multiply y double dash. Again, to make a derivative for this fraction, we use the rule. In the denominator, we have y square. We write it. And in the numerator, we have the denominator multiply derivative of numerator. So we have y double dash multiply y minus the numerator multiplies the derivative of denominator. So we will get y dash multiply y dash to be y dash all square over y square. What is the derivative of ln A? The derivative of ln A equals 0. So to get rid of y square, we multiply both sides by y square. So we have y dash multiply y plus y dash multiply y plus x y y double dash minus x y dash square. Don't forget we have x multiply y y double dash, we write it x multiply negative y dash square, it will be negative xy dash square. And it is the required. Putting y dash between bracket under the power. So the result will be x y y double dash plus 2y y dash minus x multiply y dash all square equals 0. 15. Find the absolute maximum and the absolute minimum value of the function y equals x over 1 plus x square in the interval -1 to 2. To determine the absolute maximum and the absolute minimum value of the function, we must get the critical points. And to determine the critical points, we must get the first derivative. So what is the first derivative of this fraction? It is the denominator multiply the derivative of numerator, it's equal 1, minus the numerator, we write it, multiply the derivative of denominator will be 2x over the denominator all square. And we simplify y dash to be 1 multiply 1 equals 1, 1 multiply x square equals x square minus 2x square. So the result will be 1 minus x square. X square minus 2x square equals negative x square over 1 plus x square all square. This is y dash. And to get the critical points, we put y dash equals 0. So 1 minus x square equals 0. By factorization, we will get x equals 1 or x equals negative 1. 1 and the negative 1 included on this interval. So we will find the value at the critical points and at the bounded of this interval at -1 and 2. So f of 1 equals half, substituting x equal 1, 1 over 1 plus 1 square equals half, and f of -1 equals negative half. F of 2 equals 2 over 1 plus 4, which equal 2 over 5. And we will take the maximum value and the minimum value. So a maximum value equals half, half, it is the greatest value. We compare between half and the negative half and the 2 over 5. So the maximum, the greatest number is half. So a maximum value to the function is half, and the minimum value equals negative half, because negative half is the smallest value. Question 16. Use one of the integration methods to find integral of ln x power 2 dx. Solution. We will use the rule of integration by parts as follows. We write differentiation, integration, and ln x power 2. We will take this function. We have here product of two functions. So we write ln x power 2, ln x power 2, because it's easy to make a differentiation for it, and we write dx to make the integration to it. So what is the derivative of ln x power 2? It is 2 ln x multiply the derivative of ln x, and the derivative of ln x is 1 over x multiply 2. We got 2 over x ln x. The integration of dx is x. Note that it's easy to make the integration to the function dx, so we choose dx to make the integration to it. And now we write the result. How we write it? By multiplying ln x power 2 multiply x minus the product of x multiply 2x ln x. So we write it, the integral of ln x power 2 dx equals x ln x square, this product, minus the product of x multiply 2 over x ln x, minus integration of 2 ln x dx. Note that x multiply 2 over x ln x equals 2 ln x, 2 ln x. We cancel x with x, and we have again a problem in this integration. So we have here product of two functions, ln x and dx. We divide it here to make a differentiation and integration. We make integration to the easier one, dx. The integration of dx is x, and the differentiation of ln x is 1 over x. Again, we have two functions, ln x multiply dx. So we make a differentiation and the integration. Always integration, we choose it, we choose the easier function. It is dx. The integration of dx is x, and the derivative of ln x is 1 over x. Okay, and to complete solving the problem here. So we have x ln x power 2 minus 2, we take it out and we open a big bracket to write the result of integration of these two functions. First, x multiply ln x, we write it, minus the product of x multiply 1 over x, minus the integration of the product of x multiply 1 over x. So we have minus integral of x multiply 1 over x dx, and we simplify. So we have x multiply ln x power 2 minus 2 multiply x ln x minus the integral x multiply 1 over x equals 1. 1 multiply dx equals dx, and we make the integration again. The integral of dx is x, and we take x as a common factor. We notice that x is a common in the three terms, so we take it out, and the final result will be x multiply ln x power 2 minus 2x minus 2 ln x plus 2 plus c. After you take x out, here will be 1, negative 1. Negative 1 multiply negative 2 equals positive 2.